In this video, we'll look at naming the binary molecular compound. A binary compound is a compound composed of only two elements. The first type of the binary compound is the ionic compound, which we have discussed in a previous video, where it composed of a metal and a non-metal. Another type of binary compound is a compound composed of two non-metals or metalloid, which are usually called the binary molecular compound, and they are named using a prefix system. And in this table, the covalent compound use the Greek numeral prefixes for naming the compound. So if you have one atoms, the prefix is called the mono. If you have two, di, 3, tri, 4, tetra, 5, penta, 6, hexa, 7, hepta, 8, octa, 9, nona, 10, deca. To name the binary molecular compound, we name the element in the order of increasing non-metallic character. For example, the leftmost or lower element in the periodic table is named first. Therefore, in the formula, the first element is more metallic and the second element is more non-metallic, similar to the situation when we name an ionic compound. For instance, if you have a compound composed of 3 moles of fluorine and 1 mole of nitrogen, we write the chemical formula as NF3, not F3N, since nitrogen is not more metallic as compared to fluorine. The rule for naming binary molecular compound by a prefix system is really simple. We name the element in the order given in the formula. We name the first element using the exact element name. You then add the prefix if required, derived from the Greek to each element name to denote the subscript of the element in the formula. We then name the second element using the stem name of the element followed by the suffix of IDE. You then add the prefix if required. One thing to take note is that the prefix mono is not generally used, unless required to distinguish between two compounds made out of the same two elements. Let's do a quick practice to name NF3. So the first element here is nitrogen, and since there's only one atom, we don't have to include the mono. And the second element is fluorine. There's 3 mole of it, so it's tri. The stem name of that element, fluor, followed by the suffix of IDE, right? So it's nitrogen trifluoride. Before we do some example to name the binary molecular compound, I'm going to show you an example to illustrate how the prefix mono is used. Now, if there are two common compounds of carbon and oxygen, for instance, CO and CO2, they are both carbon dioxide. And we know that CO2 will definitely be named after the prefix, which is dioxide. In this case, to distinguish CO with CO2, we will then include the prefix of mono for the oxide. So it's carbon monoxide. Let's do some practice problems. SF4, it is named as sulfur tetrafluoride. Next, ClO2, we have chlorine dioxide. Next, Cl2O6, there's 2 chlorines, so it's dichlorine. There are 6 oxygens, so it is hexaoxide. Now, one thing that you need to note is that when a numeric prefixes ending in an O or A preceded an element whose name begins with an O or an A, we will drop the prefix of the vowel. So in this case, we are going to drop A. So instead of hexaoxide, we will call it as hexoxide. Next, Cl2O7, dichlorine. So 7 oxygen should be hepta. So instead of hepta, we're going to call it hept oxide, dropping the A. Next, N2O4, it will be dinitrogen. 4 is tetra, so we're going to drop the A again in this case, so it's tet oxide. Next, P4O6, there's 4 phosphorus, so it's tetraphosphorus. 6 oxygen, again we're going to drop the A of the prefix, so it's hex oxide. And lastly, we have PCl5, so it's phosphorus. Pentachloride. Next, we will look at naming inorganic acids. Acids are an important group of hydrogen-containing compounds that have been used in the chemical reactions for many centuries. Here we merely want to see how we name this compound and how are they related to the anion that we have learned in naming ionic compound. For our present purpose, an acid is a molecular compound that yields a hydrogen ion and an anion, and when this acid dissolves in water, it forms an aqueous solutions. There are two common types of acids. One is the binary acids. A binary acid solutions form when certain gaseous compound dissolve in water. To name the binary acid, we'll start with a prefix of hydro, followed by a non-metal root of an element, and end it with a suffix of IC, plus a separate word of acids for the compound. For instance, if you have a gaseous stage of HCl that dissolve in water to form an aqueous solution of HCl, and this aqueous solutions is called hydrochloric acid. Another type of acid is oxo acids. The name of the oxo acids are related to the name of the corresponding oxo anions. Recall the suffixes that we use to name oxo anions are dependent on the number of oxygen atoms. If you know the name of the oxo anions, you can then obtain the name of the corresponding acid by replacing the suffixes as shown. ATE in the anion become IC in the acids. ITE in the anion become OUS in the acids. And for oxo anion that contain the prefixes of hypo and per will be retained when naming the oxo acids. Let's do some examples to name the oxo acids from the corresponding oxo anions. As you can see, the anion of the oxo acid is exactly the same as the oxo anion, except that the oxo acids contain hydrogen ion. Let's get the first example. Carbonates ending with ATE. For oxo acids, it will be carbonic acid. Phosphate will be phosphoric acid. Nitrite will be nitrous acid. Nitrate will become nitric acid. Hypochlorite. So for the oxo acids, hypo will retain. So it will be hypochlorous acid. Chlorite will simply be chlorous acid. Chlorate will be chloric acid. Perchlorate will be perchloric acid. Another type of binary compound is hydrate. A hydrate is a compound that contains water molecule weakly bound in its crystal, and these substances are often obtained by evaporating an aqueous solutions of the compound. Let's consider copper 2 sulfate. When an aqueous solution of this substance is evaporated, a blue crystal is formed, in which each formula unit of the copper 2 sulfate is associated with 5 water molecules. The formula of the hydrate is written as CuSO4.5H2O, where a central dot separates the copper 2 sulfates and 5 molecules of water. When the blue crystal of the hydrates are heated, the water is driven off, leaving behind the white crystal of copper 2 sulfate without associated with water. And this substance is called the anhydrous compound. Hydrates are named from the anhydrous compound, followed by the words hydrate with a prefix to indicate the number of water molecule per formula unit of the compound. So in this case, CuSO4 5H2O, we will start by naming the anhydrous compound, which is copper 2 sulfate, followed by the hydrates with a prefix. So since there's 5 water molecule, so it will be pentahydrate. So this compound is called copper 2 sulfate pentahydrate. In summary, we have looked at few different rules and methods to name the inorganic compound, including ionic compound by naming the metal ion or the cation and the anion. We learned the naming of binary molecular compound using the prefix system. We also learned how to name inorganic acids and hydrates.